Hi, my name is John. This is going to be from Pearson, Algebra 2, Common Core. Chapter 4, Section 2 is called the standard form of the quadratic function. So, what is the standard form of the quadratic function? We talked about it a little bit. Just relax, enjoy the show. Just kind of like osmosis, let's just absorb the information set. You can take notes if you want, pause it, take notes if you want. You don't have to pause it, just sleep on it. But I'm just going to do some examples and then we're going to create some information set. So the standard form last time that we talked about from section 1, which was f of x, a function of x is equal to ax squared plus bx plus c. So we're going to revisit the standard form. I like to call this the standard state. It's a different state than the vertex state, right? So your a value is the coefficient. This is called the leading coefficient, by the way, because it's in front of the x squared. The degree is, remember we talked about degree last time? The degree is 2. Where does that 2 come from? That 2 comes from the highest power, which is God, right? So if I say degree, think of it as God. It's the highest power, okay? So the highest power is 2. That's called the leading coefficient. Then you have a linear term. Then we have a constant term, okay? So we're just going to do an example and see what it looks like. The function looks something like this, equals 2x squared plus 8x minus 2. We don't know what's transforming last time from x direction or the y direction. How much, kind of like, is it a vertical stretch? Is it upside down, right side up? We do know one thing. The only thing that we know is our a value. This a value is our a value right here, which happens to be greater than 0. What does our gut say when a is greater than 0? Meaning it's positive, right? We talked about it in section 1 last time. Our gut says that if a is greater than 0, I'll give you a hint. Is it a maximum or a minimum? You have a 50-50 chance, odds, 50-50 shot. Pause it if you want to see what the answer is. Okay. Greater than 0, it's a smiley face. It's going to be a right side up. It's a parabola. They call it opening up, whereas this is opening down, which is like a sad face, right? So we know that it opens up. Well, we don't know what the vertex is, so I'm going to graph it on this graphing calculator and show you how to use this graphing calculator a little bit. Press the y equals button. You got to turn it on first. It kind of helps a little bit. Y equals button, and you're going to go to this function. 2, the x is right here, second row, second column. If you can see, 2x squared, and then use the square button, and then plus 8x. There's the x button, and then minus 2. Okay, and then we're just going to graph it. Press the graph key right there on the right. It looks kind of like this. We know that, wow, it is up, right side up. It opens up, basically, right? It's a right side up calculator. And the vertex, to figure out what that vertex is, you have to go to calculate. Sorry about that. You have to go to calculate second and then calculate right here. And what you want to find is the minimum value, right? That's what you call it, minimum. You use your right arrow key where it goes to the right of the vertex. Can you see it? It's to the right of the vertex. Press enter. And then you go to the left, to the left of the vertex first, and then to the right of the vertex. Okay? So it's going to try to calculate the minimum point between those 2 points, those 2 intervals. As soon as you press enter, it comes out to be 2 and negative 10. Is that right? 2 and negative 10. Vertex happens to be 2 comma negative 10. Oh, excuse me, negative 2. There's a negative right there. Negative 2, negative 10. Okay? I know that's negative 2, negative 10. Here's -2 and -10. It's going to look something like this. So we graphed it. What is your vertex? We found the vertex using the calculator. What is your AOS? AOS is the axis of symmetry. It's located right over here. I'm going to use red marker for that. Remember, this point was -2, comma, -8, -10. Remember, we told that the AOS, axis of symmetry, is the x-coordinate. It's going to be x equals -2. So we found the axis of symmetry. What else do we need to find? We found out, is it a max or a min? Well, we know that it's a lower portion, so it must be a minimum as well. So it's a minimum from your vertex. And we have to tell its domain. What is this domain? The domain is always all real numbers for a parabola, right side up or upside down. -infinity to infinity. What's your range? In interval notation, it's going to be at -10 and anything that goes along the y-axis, right? So it's going to be from -10 inclusive to positive infinity. Don't forget, infinities always end with parentheses, just like here and here. Okay, this means all real numbers. This means inclusive of -10 to infinity. So the next question lies is, how do we find the vertex without a calculator? Good question. So let's look at example 2 now. Let's say the function f of x is equal to 2x squared plus 8x minus 10. And I'm just going to give you what the vertex of your x-coordinate is. It's going to be -b over 2a, comma, and then you have to find the y value for that. Okay. This one seems to be another formula you have to memorize. It's actually not so difficult. This is just like x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Get rid of all this junk. There it is. Whoop, there it is. -b over 2a. So simple. There's your a. That's your b. Coefficient in front of your linear. That's your c. Got it? Whoop. You see this? It's better? Okay, better. Okay. So, your x-coordinate of your vertex is -b over 2a. Always write the formula down until you get it memorized forwards, backwards in your sleep. -b, which is -8 all over 2 times 2. That's my a value. Simplifying that, I get -8 over 4, which is equal to -2. That's your x-coordinate. So it's going to be -2 f of -2, whatever your y value is for that coordinate, right? Let's plug it in. F of -2 is equal to 2 times -2 squared plus 8 times -2 minus 10. PEMDAS, by convention, says we do -2 squared, which is 4 times 2 is 8. 8 times -2 is -16 minus 10. 8 minus 16. Wait a second, something's wrong here. That's going to be 2 squared, which is 4 times 2 is 8. 8 times -2 is -16, and then minus 10. Oh, I'm sorry. I'm going to rewrite that as -2. Okay, as -2. Minus 2. The reason why I did that was because I'll tell you a little bit reason later on, okay? Anyways, 8 minus 16 is -8. Minus 2 is -10. So your vertex is at, what was it? -2, comma, -10. Whoop, there it is. Wow, it happens to be the same example that we did earlier. 2x squared plus 8x minus 2. I looked at it, I go, oh, it didn't add up correctly. So I went back and I miswrote example number 1, which was 2x squared plus 8x should have been minus 2 right there. I imprinted minus 10. So that's why it should have been minus 2 right here. Should have been minus 2 right there. Okay? So there's your vertex. That's how you find your vertex of your quadratic equation. Okay? If you have any questions, let me know. Oh, what about something like this? They also want you to find one other thing as well. They want you to find your y-intercept. How do you find your y-intercept? What is the process by which you find your y-intercept? Your y-intercept is when your x value is 0. In other words, it's going to be 0 comma something, right? Well, let's plug it in. If I plug in 0 in here, f of 0 is equal to 2 times 0 squared plus 8 times 0 minus 2. 0 squared is 0 times 2 is 0 plus 8 times 0 is 0 minus 2. It's going to be 0 comma negative 2. Looking at this equation, let's look at it one more time. I'm going to turn it back on. You notice that the y-intercept is going to be negative 2, approximately right over there. And so we found it. Okay? You can eyeball it if you want. You know, if it's up here, if it intercepts the y-axis, which is positive, then it's not quite right. So we got to go back down. And we notice that it's going to be probably negative 2 when we eyeball it. So everything makes sense. Check. Good luck with Chapter 4, Section 2 of your standard form. Don't forget, the standard form is ax squared plus bx plus c. Okay? Good luck.